Assalamualaikum dear students, hope you are fine by the grace of Almighty Allah. Welcome to NIEVS Home School. I am Sabreena, Haque, Assistant Teacher of Science, National Ideal English Version School, Day Shift. Dear students, today I am going to take a science class for class 8 student based on chapter 7, and this is the first part of our chapter. So let us move for our today's topic. The name of the chapter 7 is the Earth and Gravitation. Dear students, this is the picture of Earth and this is the picture of neutrons, and you have heard the story that Newton was sitting down a apple tree and an apple falls in front of you. Then that time he thought about that why this apple fall to the ground. There may be any attractive force. From this thinking he just give the gravitational force, law of gravitation and gravitational force, and that is the today's topic. Now come to the introductory part of the chapter. Newton put forward the law of gravitation that all particles in the universe attract each other by a force which is proportional to the product of their masses and inversely as the square of their distance apart. Does this force of attraction vary from place to place? On what factors does this force depend? In this chapter we will discuss gravitation, gravity, acceleration due to gravity, mass and weight. Come to the gravitation. If we jump, we cannot go up very much. We fall back to the surface on the earth. Fruits fall from trees on the earth. Why do all this happens? The reason is that the earth attracts these objects towards it. It is not only the earth that attracts us. In fact, all objects in the universe attract one another. The universal attractive force is called gravitation. Dear students, this is the definition of gravitation. You might have heard the story of Newton and the fall of an apple from the tree on the ground. As the story goes, Newton was sitting in the garden and was engaged in thought. Suddenly he saw an apple to fall on the ground. The question came in his mind, why did the apple fall towards the ground? Something must be attracting it towards the ground. After much speculation, he came to conclusion that the earth attracts every object towards it. Later on, he comes to more specific conclusion that it is not only the earth but all objects in the universe attract each other towards their center. Attractive force that exists between any two particles in the universe is called the gravitational force. This is the definition of gravitational force. The attractive force that exists between any two particles in the universe is called gravitational force. Now come to the Newton's law of gravitation and gravitational force. Each particle in the universe attracts every other particle with a force which is proportional to their product of their masses and inversely proportional to the square of the distance between them. This is the Newton's law of gravitation. Newton developed an important theorem, that is gravitational attraction between two homogeneous spheres is proportional to the product of their masses and inversely proportional to the square of the distance between their centers. This is because of spherical bodies, the whole mass of the sphere can be assumed to be at the center of the sphere. That's why we have to count the distance from the center of the sphere, provided the observer outside the sphere and the sphere is homogeneous. If we assume the 2-point object or spherical bodies have masses m1 and m2 and the distance between them is d, then gravitational force F acting between them is given below. That means F equal to capital G multiply with m1 m2. This is the mass of two spherical body and inversely proportional to d square. That distance is from the center of m1 to the center of m2. Now here G is the gravitational constant. Here G is the constant, is proportionality. It is called the universal gravitational constant. This means that if two spherical body, each of which has mass 1 kilogram and the distance between them is 1 meter, the attractive force between them is G, is magnitude. This is the value of G. If the bodies are spherical, the distance is measured from the center is spheres. Now, from the formula of gravitation, we found that if the distance between two objects is fixed and the product of their masses is double, the gravitational force becomes double. When the product of the masses is 3 times, the corresponding force will be 3 times greater. If the distance between the object double, keeping the product of the mass constant, then the corresponding force will be 1/4. And when the distance made 3 times larger, the corresponding force become 1/9 of original force. That means it depends on the mass and it depends on the distance too. The earth moves around the sun due to the influence of gravitational force, just as a ball attached to a string can be made to revolve because the tension of the string. Now answer, why do planets revolve around the sun? Because of the gravitational force. Now come to gravity. We have learned about gravitation and gravitational force. Now we are going to learn about gravity. Gravity and acceleration due to gravity. Gravity. We know every material or particles in the universe attract each other. When the mutual attraction involves any two objects in the universe, we call it gravitation. If one of the object is the earth and the attraction on the object is due to the earth, we call it gravity. When a cricket ball is thrown upwards, it falls back to the earth due to the attraction of the earth. Just the earth attracts the cricket ball towards it with a downward force. The cricket ball attracts the earth with the same upward force. But since the earth is very heavy compared to the cricket ball, it moves very little towards the cricket ball. On the other hand, the cricket ball having little mass compared to the earth, acceleration towards the earth, the accelerating force due to the earth on any object near to it is called gravity. This is the proper definition of gravity. The acceleration force due to the earth on any object near to it is called gravity. Thus, the attractive force between sun and moon called gravitation, but the attracting force act between you and the earth or between your science book and the earth will be gravity. Acceleration due to gravity. We know that a force is applied on an object, its velocity increases. The increase in velocity per second is called acceleration. The force of gravity also causes acceleration. This acceleration is called the acceleration due to gravity. The acceleration due to gravity is indicated by small g. Since the small g is from the acceleration, the unit that acceleration that is meter per second square. Let us assume capital M is the mass of the earth, small m is the mass of an object near the earth, small d is the distance between the object and the center of the earth. From the formula of gravitational force, F is equal to capital G multiplied with capital M multiplied with small m divided by d. Again we get from the relation between force and acceleration, the force of gravity is equal to mass multiplied with acceleration due to gravity. That means F equal to mg. Then mg is equal to, because both are F's value, then we can write mg equal to gmm divided by d square. From here we can find out this 2m cut down and we can find out the g's value by dividing the gravitational constant and the mass of the earth divided by the distance between the object and the center of the earth. And we know both the mass of the earth and the gravitational constant both are constant, and this can't be changed. Only the distance can be changed. That's why the gravitational due to acceleration due to gravity is depends on the distance between the center of the earth to that object. In this equation, m is absent on the right side. That means the acceleration due to gravity does not depend on the mass of the body subjected to the gravity. It only depends on the distance. Since g and the mass of the earth m is constant, the value of g depends on the meter d from the center of the earth. Thus, the value of g is independent of the mass of the object but is not independent of its position. This means the value of g is different in different places. That means if we are in pole, that time the value of g will be 9.83, and if we are in equator place, that time our value of g will be 9.78. Now come to the variation of acceleration due to gravity. If the distance of the body at the surface of the earth measured from the center of the earth, that is radius of the earth, that means we can write here in place of dr, then the g will be capital G multiplied with capital M divided by r square. Since the earth is not a perfect sphere, r is not really constant, because when we are saying earth is an sphere shape, but it looks like orange. That means in the polar zone the radius of the earth is lesser than the equatorial zone. So the value of g is not equal everywhere at the surface of the earth. As we move from the pole to the equator, the value of r increases and the value of g decreases. At the equator, the value of g minimum, that means 9.78. This is the value of g in the equatorial place. The value of g in the polar region is 9.832 meter per second square, because there the value of r is lesser than the equatorial zone. At the earth's surface, for the convenience of calculation, the value of g is taken 9.8 meter per second square. At the surface of the earth, the value of g is 9.8 meter per second square. It means for a freely falling body near the surface of the earth, the velocity increases by 9.8 meter per second at every second. If a body is allowed to fall from above, it reaches the surface of the earth due to the force of gravity. If we allow a piece of stone, a piece of paper to fall from the same height, will they reach the surface of the earth at the same time? Since the acceleration due to gravity does not depend on the mass of the body, therefore acceleration acting on the both stone and the paper are same. As a result, both of them should be expected to reach the surface of the earth at the same time, but it is not happened really. The stone will reach the surface of the earth before the paper. This is because of air resistance. So to doing this experiment, we need a vacuum place. We should apply the vacuum place for doing this experiment. That time the stone and paper will be fall in the same time. In absence of air, they would reach the ground at the same time. Now come to the mass and weight. In our day-to-day life use of language, we often make no distinction between mass and weight. But in physics, the two words means different entities. In fact, when we say that the weight of a bag of rice is 50 kg, we actually refer their masses. In this respect, the use of word weight of an object is scientifically wrong. But what is the difference between mass and weight? Come to mass. All objects made of materials, mass of an object refer to the amount of materials present in an object. This is the definition of mass. This property of the material does not depend on location, shape or state of motion according to Newtonian physics. That means every time the mass will be same. The mass of an object what will be in the Earth's surface, that will be on the moon surface too. The mass of the object depends on the number and the kind of atom and the body by which the object is formed. The international unit of mass is kg. A heavy mass is expressed by the unit of tons, and 1 tons is equal to 100 kg. Small mass is expressed in the unit of gram. Thus, the mass of your pencil is 5 gram, 1000 gram makes 1 kilogram. More appropriate meaning of mass is Newton's law, that F equal to ma. Now, mass of an object, thus the mass of an object is the ratio of F and acceleration. Here F is the force and A is the acceleration. If the mass is greater, it resists the increase of velocity more, for it the same applied force. Mass is thus related to the inertia of the motion. Now come to the weight. We know that if a body is thrown upward, it comes back to the earth due to the weight of the body, which pushes the object towards the earth. We can say the force of gravity causes the downward pull. The force by which the earth's surface attracts an object to its center is called weight. It is the definition of weight. If the mass of an object is m, then the acceleration due to the gravity at the place is g, and the weight of an object will be w equal to mg. Then where F equal to ma, and there we are getting the weight equal to mg. That means mass multiplied with acceleration due to gravity. The unit of weight is Newton. The unit of mass is kg, and the unit of weight is Newton. The weight of an object with mass 10 kg will be W is equal to mg. M means 10 kg multiplied with 9.8 Newton. It will be 98 Newton. Generally, we can determine the weight of an object by using a spring balance that is given in the first page of your chapter. Now come to the relation between mass and weight. We know that the amount of material in an object is its mass. It is a constant parameter and which does not change due to the change of location of any height above the earth. If an astronaut has the mass 75 kg, it will remain unchanged when he is in the surface of the earth, or on the surface of the moon, or in the orbit of the moon or earth. That means every time his mass will be 75 kg. The amount of material by which an astronaut is built does not change due to the change of position, and that is why the mass remains unchanged. Since the mass of an object is constant, the weight changes due to the change of the value of g, because we know the weight is equal to the product of mass and gravitation due to acceleration due to gravity. That's why we know the value of g changes from place to place. That's why it depends on the value of g. As one goes more and more above the surface of the earth, the weight of an object becomes less and less. The reason for which the value of the acceleration due to gravity changes are also the cause of the changes in the weight of an object. The weight of an object is not an fundamental parameter. For example, an object may have weight at one place and may not have any weight at another place. At the center of the earth, the value of acceleration due to gravity is 0. Dear student, that is most important thing. In the center of the earth, the value of gravity is 0, and therefore the weight of an object there must also be 0. At a distance space where there is no gravitational force, the weight of that object must be 0. That means because it is the product of acceleration due to gravity and the mass, if the value of g will be 0, that time that object's weight will be 0. The value of acceleration due to gravity due to gravitational force at the surface of moon is 1/6 compared to that at the surface of the earth. You can find out the Newton's weight. You can find out the weight of 1 kilogram of material at the surface of moon is about 1.63 Newton. This is because of the gravitational acceleration due to gravity decrease, that's why. Now come to the weight of an object is a location depends on this distance from the center of the earth. If the distance is increased, the force of gravity due to earth at that point decreases. As a result, the weight of an object there decreases. At the surface of the earth, the weight of the mass 1 kilogram is 9.8 Newton, but at a distant point from the earth, its weight decreases with the increase of distance. The weight of an object varies slightly also different position on the surface of the earth. On reason for this that the earth is not a perfect sphere and the acceleration due to gravity is not same at all the point of earth's surface. However, this variation is so small that it can detected by only the using a very sensitive weighting machine. We neglect the variation in most of our calculation. An object will weight maximum at 2 poles, and this places 1 kilogram will weigh 9.83 Newton. Now at the equator the weight will be least with the value of 9.78 Newton. At the equatorial point the weight will be 9.79 Newton. Now come to the weight of the body increases in proportional to its mass. Therefore, the instruments which are used to determine weight can also be used to measure the mass of the object. Often, spring balance is calibrated. The unit of kilogram balance is weighting instrument are calibrated in such way that we sometimes use the kg unit for measuring both mass and weight, and it is cause a wrong practice. The weight of a form of force for the scientific calculation, and it should be expressed in the unit of Newton, and only for mass we can use kg. When we buy a packet of rice or milk on which 1 kg is marked, we understand that each of these packet has 1 kilogram mass, but their weight are not 1 kg. On the surface of the earth, they will weigh 9.8 Newton. These packets will weigh different from the planets to planets on the moon, although their masses will remain unchanged. Dear students, you have to make 5 MCQ. This will be your homework number 14 from this part of the chapter. Dear students, I have finished my today's topic. Hope you have understood. Read the chapter properly. This is too much important chapter for you. Thank you. Allah Hafiz.